Hello everyone. Welcome to ChemTalk Education. In today's video, we'll be discussing polyatomic ions and its importance to cellular energy transfer. So let's dive right in. First of all, what are polyatomic ions? Well, the prefix poly in polyatomic means many, and atomic is atoms. Ions are charged atoms. So, polyatomic ions are several atoms bonded together with a charge. Let's look at some examples of polyatomic ions. A common one is hydroxide. We write this as OH-. This just means that one oxygen atom and one hydrogen atom are bonded together. And this group of hydrogen and oxygen has a charge of -1. Ammonium is another polyatomic ion, and we write this as NH4+. So here we have one nitrogen atom bonded to 4 hydrogen atoms. And this group of nitrogen and hydrogen has an overall charge of +1. And this is all polyatomic ions are, atoms bonded together with a charge. There are many polyatomic ions that exist in our world, but some are more common than others. Take a look at this list over here on the screen of some common polyatomic ions. Because polyatomic ions are such a foundational part of chemistry, it's a good idea to memorize these. Note the charge and number of atoms bonded together for each of these polyatomic ions. Now, you may be asked to write ionic formulas for polyatomic ions, so let's learn how to do that. For example, let's write the formula for aluminum sulfate. By looking at your periodic table, you can determine aluminum's charge to be +3. Check out our video on ions and charges if you're confused about how we did that. Sulfate is a polyatomic ion, so if we look at our list over here, we can see that it has a charge of -2. Our goal is to have the charges balance out. In other words, the sum of the charges must equal 0. Right now, our charges are not balanced out, so we need to find the least common multiple of the charges. The LCM of 2 and 3 is 6. Therefore, we need 2 aluminum atoms because its charge of 3 times 2 equals 6. And we need 3 sulfates because 3 times -2 equals -6. And that 6 and -6 will cancel out. So our answer here is Al2SO4 3. Notice that when we write how many sulfates we need, we put the parentheses around the sulfate and then write the 3 on the bottom. This is standard for all polyatomic ions because it shows that the number on the bottom applies to the whole compound. Let's try another example together. Write the ionic formula for ammonium nitride. Ammonium is a polyatomic ion, and our list tells us that it has a charge of +1. Nitrogen has a charge of -3. Now ask yourself, do these charges cancel out? And the answer to that question is no, they don't. Because nitrogen has a charge of -3, we need a +3 to cancel that out. Therefore, we must have 3 ammoniums in this compound in order to cancel out nitrogen's charge of -3. Our final answer is NH4 3N. Again, take note of the parentheses around NH4. That's very important to include for the sake of clarity. Since we've done a few practice problems together, go ahead and try some on your own. Up here on the screen are some practice problems regarding polyatomic ions. Try these out and check your work with the answer key posted in the description box down below. I mentioned earlier that polyatomic ions are a foundational part of chemistry, and that's because they're everywhere. One super cool example is seen in cellular processes. Within our cells exists ATP, or adenosine triphosphate. When food molecules are broken down, ATP takes this energy and transfers it to other cellular processes that require energy. ATP is made of adenine, ribose sugar, and as the triphosphate in the name may have indicated, 3 phosphates bonded together to the ribose. Phosphate is a polyatomic ion, like we just learned. And between the bonds of phosphate is where the energy is contained. So ATP moves phosphate groups to other molecules in order to transfer this energy. Before we end our video, let's review what we discussed in today's lesson. Polyatomic ions are several atoms bonded together with a charge. There are many polyatomic ions, but you should memorize the ones that we showed throughout the video. We can write ionic formulas by looking at the charges in the compound and determining how to make them cancel out by using the least common multiple. Then we write the formula with the appropriate amount of atoms, and that would be our finished answer. Polyatomic ions are present in cellular energy transfer, which is achieved by transferring the polyatomic ion phosphate to other molecules. And that is all for our lesson today. Thank you so much for watching, and be sure to visit us at www.chemistrytalk.org to access more cool chemistry content. Bye!